My second presentation is a case study, and it describes water mist technology, how it's used for power infrastructure protection. Now, fire protection in power infrastructure is an ever-growing topic. A lot of the major cities are constantly growing, and this requires refurbishment and also extensions of power infrastructure networks, and to make sure that power is available at all times. And this is where the transition of power through cable tunnels is key, but also transformer substations are a key application field which fire protection has to look into. And this is where water mist technology in both fields has been around during the last 20 years. It has been looked at since 20 years, and systems have been installed based on various standards, European standard, for example, and approval and certification bodies like VDS have issued approvals for these two type of applications since many years. And in the end, water mist has been seen as a good technology for the application fields because it makes sure that downtimes in case of a fire are reduced to a minimum. Now, based on this basic introduction, I want to present two case studies to illustrate how water mist has met the customer's requirements and needs. The first one is a cable tunnel case study of Singapore Power, and the second one is the protection of transformer substations in Dubai. Now, in Singapore, it's a growing city where the operator of the power grid network, Singapore Power, has to ensure to 1.3 million industrial customers and commercial customers the power with their power network. And this is where, due to the constant increasing power demand, the existing power network, the power distribution network, was not sufficient. So Singapore Power decided to invest into a new built power supply cable tunnel, which makes sure that high voltage is available to the entire city at all times. And this is where a network of 35 kilometers of high voltage cable tunnels had to be constructed in 60 meters under the surface to connect all users in the city. This actually consists of two intersecting tunnels, one from the north to the south and one from the east to the west. And these cable tunnels are then accessed from the surface via 14 utility buildings where the cables are routed to the surface. In the north of the Singapore Peninsula, there's the key power station from where the power is then routed into this area. Now, the connection to the power station has already been equipped with water mist technology in 2005. So a 1.7 kilometer long cable tunnel with 3.5 meter diameter has been equipped at that time based on the existing certification that was available at that time. But now, since the power requirements have increased so much, the challenge was that the newer power distribution network had to be quite large, much larger than the 3.5 meter in diameter to accommodate all the power cables that were required for the city. So now the diameter, the cross section of these 35 kilometer long high voltage power transmission tunnels has a diameter of 6 meters and extends to 9 meters at the shaft area. So this was a real challenge because the customer was happy about the performance of water mist technology in the field, but the test results and the certification that was carried out previously could not be used for this size of project. So actually this has led to develop a fire test protocol to prove that the system is suitable for the application. And this is what is possible with this technology, because we have this performance-based approach of water mist. So in this case, a fire consultant company, the end client, the fire authority, has jointly developed a fire test protocol based on a thorough risk assessment that was carried out. These large cable tunnels, they route power cables in cable troughs, and there are so connection points between these cable troughs, which of course have to be protected. In addition, along these long cable tunnels, there are service vehicles running through them, which represent an additional fire risk, which also have to be looked at into this fire test to demonstrate the efficiency of the system. A further challenge has been the longitudinal ventilation conditions, which you have along the cable tunnels, which are up to 5 meters per second, which is also an additional challenge for water mist. So the fire test protocol has been developed, taking all these challenges into account, and different fire scenarios were developed with fires along the cable troughs, fires allocated to the service vehicles, hidden fires, and exposed fires. And these have been carried out under the ventilation conditions up to 5 meters per second, with fire sizes up to 5 megawatts, so quite extensive fires, into a mock-up of the tunnel with 60-meter lengths and 6-meter diameters. And all these tests have shown that the water mist system could very efficiently control the situation, cool the area, and make sure that the fire can be tackled by the fire services. So finally, the system has been installed into the cable tunnel on the total length of 35 kilometers as a deluge system with open nozzle. In total, more than 25,000 nozzles have been installed in this tunnel. The whole tunnel has been zoned in virtual zones of 33-meter lengths. So a total of more than 1,100 section valves have been installed, and these section valves are then opened, are operated by the fire alarm system, the fire detection system, which is a linear optical heat detection system along the tunnel, which then allocates the fire and makes sure that the 3 adjacent fire sections at the fire zone are activated to successfully tackle the fire and take care of the fire in this area. In addition, the cable supplies at the equipment buildings and the cable routed through the shafts towards the tunnel, of course, are also protected by the water mist system. So the small bore pipework that is needed with this technology has been beneficial. You can imagine with 35-kilometer lengths, the hydraulic calculation is quite a challenge. So the maximum pipe sizes for the distribution of the water along the tunnel has a size of 80 millimeter. Of course, within the section is far smaller pipe sizes. The good about this tunnel was that a lot of pipe fabrication could be carried out. So a total length of 75 kilometers of stainless steel pipework has been installed, but it could be installed in a very short time because everything was pre-manufactured off-site. To make sure that water is available at the nozzle in a short time after fire detection, the main pipe is water pre-filled, so it's wet, and a jockey pump makes sure that we are monitoring the main pipe and assuring that it's checked for any leakages. And in 6 different pump station, water is pressurized to 140 bar and then made available to the 35-kilometer long tunnel by a main pump unit which has 10 duty pumps and 1 redundant pumps, and this whole thing has 100% redundancy. That was a special requirement by the client. And each of the pump rooms is fitted with a respective water tank this water tank contains drinking water quality and offers a 30 minutes autonomy of the system. So this is the first case study. The second one I want to talk about are the transformer substations in Dubai, where DEWA, Dubai Electricity and Water Authority, is running the power supplies to the cities. Also here, of course, Dubai has grown over the year, so DEWA had to extend its power network and also the related power transformer substations to make it suitable for the increased power demand. And they looked into different technology and due to the water sensitive area in the Middle East, they found water mist technology, an interesting technology to install into their transformers. Now, the challenge into this project has been that they had a number of transformers of a size which was covered by previous approvals, for example, by BDS, but a number of these transformers were quite large. These large transformers, there was no approvals or design parameters available. So again here, based on the standards, specific fire test protocols had to be developed with the client for transformer sizes of up to 8 meter lengths, up to 6 meter width and 5.5 meter height into an enclosure, but also these enclosures are not fully closed. So we have an open ceiling, we have a 60% front opening, and all of this, of course, had to be taken into account into the fire test, because this will allow wind to enter the area. So ventilation conditions up to 4 meters per second can be present around the transformers. So this testing that was carried out formed the basis for the installation of the first water mist system into these large transformer stations in 6 substations with 42 transformers in Dubai. And the test mock-up that was used, you see on the upper picture. So it's a full-scale fire test that was done with a real-size transformer and the real-size surrounding around it. It's an open test mock-up with the front opening of more than 60%, and forced ventilation makes sure that we have realistic condition in the test. Various different tests were carried out with the pool fires on top of the transformers, at the bottom of the transformers, but also flowing fires from the top down were carried out with fire sizes up to 10 megawatts, so quite large fires. And it could be demonstrated that all these different fire scenarios could be successfully extinguished within maximum 15 minutes time, which was a requirement from the fire test protocol. And based on the results of the fire test, the system was installed as a local protection system with open nozzles being routed in 2 layers around the transformers. Underneath the transformers, a grid soil was installed to make sure that the maximum surface of a transformer oil spread would be limited. The activation of the system in this case is by the either fire detection system or by an activated glass pipe hydraulic sensor line, which was connected to the system. And this then, of course, has met the requirement of the clients. From the installation point of view, the water mist system has given some benefit. The upper photo shows on the right side the pipe sizes that were used for the water mist technology. On the left side, you see conventional low pressure technology, and you see that higher pressure technology allows to bring down pipe sizes substantially, which of course for the existing transformer stations was beneficial because it was easier to integrate the system and to minimize interference with the service and maintenance requirements from the clients. Also here, from the centralized pump unit in the pump station, the main pipe towards the section valve is pre-filled with water. A jockey pump makes sure that it's monitored, this line, so that the time between system detection and full water spray from the nozzle is reduced to a minimum. In this case, we have electrical driven pumps, 4 times 120 liter per minute with 100% diesel unit redundancy. And again, there's a dedicated freshwater tank with drinking water quality offering 30 minutes autonomy with a 15 cubic meter size. So what these two case studies shall show is that water mist technology, it offers a proven and certified solution to ventilated areas, cable tunnel areas, transformer substation areas. Due to the ability of water mist to its physical property, it provides a very effective system. It has a very high cooling effect, so it creates a safe environment to people in the area and meets the requirements by operators to have as short downtimes as possible with an environmental and sustainable technology. Thank you very much.